Hello, everybody. Thank you very much for being here. It's really the first time for me to give a talk before and after lunch at the same time. Interesting situation. So, our topic today, time-related range types. You probably know that Postgres has a huge amount of data types. As a matter of fact, you can have a good overview about them later in the afternoon in the talk of Andreas Scherbaum. We are going to focus here on those specific range types, which are basically a kind of a collection of information. I'm going to give you a short overview about the types in general, how they work, which kind of functions we have, operators, and that kind of stuff. And then we're going to move on and look more specifically at some use cases that we have been implementing in the company I work for, which is the Center of Economic Research of the Institute of Technology in Zurich, Switzerland. And also some use case that we have been implementing in the PostgreSQL user group. So to myself, as I said before, I work in the IT department of the Economic Institute, obviously in database. We have many different kind of databases. We are moving towards one single technology, which is PostgreSQL. This is also one of the main reasons I'm here today. Besides, I founded together with a few friends 2 years ago the users group in Switzerland, and we organize also a PG Day in Switzerland. You are very welcome to join next year. It has been last week on Friday. So for this year, it's gone, but you still have a chance next year to come. Okay, range types. A range type is, you can look at it as a composite type. It has a beginning and an end. It also can have an open beginning and an open end. But basically, you always have two information which are limits, right? And natural candidates for this kind of data types are numbers, dates, time. You know, time and dates actually in a PC are numbers. So from that point of view, there's not very much difference. What's important to understand is that you cannot have gaps within a range. So you have a beginning and the end. They might be included or not. But at the end, in between, you must have all values. So you can't have, let's say, a range from 1 to 10 without having 7 and 8 in it. It's not allowed. Actually, you're going to get an error if you try to do that, joining two ranges at the same time, which would lead to gaps. So, like any other little bit exotic types, we always need a kind of text representation of them. In the case of ranges, it was quite easy because it comes from mathematics. So as a matter of fact, the notation that is used is very similar to that you would find in any mathematics book about ranges. So as you see here, this is an example. We have two dates, and depending if it's included or not included, the range covers a different amount of number of days in this case. So as I said before, you can have empty ends. That means it's always. Yes, in this case, it's from infinity to infinity, or always. In which cases you might need this kind of information in your database. It depends on the use case that you have. For instance, if you use them in order to allow access to specific information, you might have some administrators who are always allowed to use those to access this information, right? So there are two ways how you can generate or create a range type. One is using the textual representation and cast it to the type. This is the case. Voila. So, my finger a bit too thick. This is this case here. We have a beginning, an end, and we have the casting, using the casting operator, which is typical for Postgres. Now, in this case, as you see, we have an including. This day is included in the range, while this one is not, right? we could make it differently. We could have the same date expressed in a different way using these inclusion or exclusion operators. There is also kind of a constructor, a function that you can use. And the nice point in it is this H range type, which is defined in Postgres. The constructor function is exactly the same, has the same name as a data type itself. So in case of date range, it's called date range. You put the beginning, the end, and the third operator, the third parameter, is the one that where you give if those bounds are included or not. If you don't do that, if you leave it out, the default is exactly this one, right? By the way, if you have any questions, you can stop anytime, just to make if anything is not clear or whatever. Okay. As I said before, in this case, you can put null in it. And so you are going to create an open bound, a range which has one of the bounds that is open, since always or until always. Now, as a word of recommendation, I said before, you can use these inclusion and exclusion boundaries as you want. As a matter of fact, in some cases, if your data, if your range contains ordinal values, that means like integer numbers or dates, what Postgres is going to do is to modify your entry to which one that suits the default value, right? These and this up here are exactly the same range, but they look different, but it's the same. So why is it important? We're going to see that you have functions where that you can use in order to extract information from the ranges. So you can, usually you want to know which is my lower end, which is my upper end, right? And you're going to get exactly the number or the date that is in the range. So you need an additional information, it's included or not, in order to make or to display this information. Let's say, for example, in a user interface on the web, right? By the way, this problem with the modifying your entry in another way does not apply if you have rational data. For instance, if you have numerics, a numeric type, and you're defining that your upper end is included, this is exactly how it's going to be represented within your database. And the reason is that it's easy to define what is included, but as soon as you have this end, this, let's say you have 13 dot whatever, 4, 5, 6 included. Next question is, what is the next number? So it's impossible to say that an infinite number. So that's the reason why it's not modified. So there are operators and functions. These operators here are used mainly because of for enabling the creation of bit-trace index on the type, right? So that means you can use them actually in indexes too, and in particular we are going to see that in exclusion indexes, which makes it very handy to check for or to avoid overlapping time ranges. Then we have some more specific range functions and operators, which actually are not don't exist in other types for the simple reason that don't make sense. And finally, you can join or combine, put together ranges or compute differences. And what you get from those operations is illustrated here. We have here two ranges, A and B. If you make an intersection using this operator, star, you're going to get exactly this range, right? If you make a union, obviously, you get all of them. Now, if you try to make a union out of those two, you're going to get an error. For the reason that I said before, that you must have all values in between two. In this case, they are not there, so that would lead to an error. With a difference, you have to be careful which range you put first, because it makes a difference if you compute A minus B or B minus A, as is illustrated here. This is a very helpful one, overlaps. It tells you if there are any value between two ranges that overlap, right? Now, the containment operator is also very helpful. You can check for if a range is contained in another range, or if a value is contained in a range. This comes very handy in the use cases I'm going to show you later on. And finally, this case here, that means basically one range is exactly, two ranges are exactly besides each other. There are no gaps in between. Myself, I cannot think now of a useful use case for that, but the operator is there, so if you need it, you can use it. So the anatomy of a range type, we have seen that already. We have functions, as I said before. With those functions, you can get the values that are in the range itself. As I said before, you're going to get exactly that value. That means if you entered a non-inclusion here, you're going to get actually the day after, right? Excuse me, the day before, which is included. So as I said before, that might be quite confusing sometimes. And for that reason, you have also additional functions that give you the information if the upper or lower range bound is included or not. So using those two information, you can actually, you have all the information that you need in order to make your logic in the user interface. Then there are some additional helpful functions. You can check if a range is open in one way or the other, or both. You can check if it's empty. In databases, as you know, empty and null is not the same. That means null means it's not set, right? But if it's empty, that means there are no values in it. It is set and there are no values. In the case of date ranges, that would mean never, right? And finally, we have this merge function. This is similar to the union, with a difference that you can have gaps. So actually, what the result that you're going to get from there is a range that comes from the lower bound from here to the upper bound there, right? And will include also all values that are between them, if there are some missing. Obviously, there was some situation that this was necessary, and that's the reason why the developers of Postgres have introduced it. So, so far to the theory, how they are used, the functions there are, and which kind of operators that you can use. Now, are there any questions so far? If that's not the case, then we are going to focus now on some use cases. As I said before, I work for the Economic Institute in the Federal Institute of Technology in Zurich. That means what we do, or actually what economists do, is to compute indicators to make forecastings about how the economy or the business cycles are going to develop in the next few months. In order to be able to do that, what we do is actually gather information using surveys from 8,000 to 12,000 companies every month. And those companies answer the survey using a paper questionnaire, and some of them do it online, about half-half. Now, the online questionnaires look like this. This is a retailer survey with some questions in it. And what we have here is this questionnaire, actually in our database, being a document, ends up being a JSON, right? So this is how it looks like in our database. We use JSON because for us it is quite important to have the whole information in one single place, and we can make a history out of it, which is much easier if you have everything in one single row, right? As a matter of fact, what you see here is just one language. What we have in reality, we have the entries for all languages that we use, which are 4, Italian, French, and German, which are spoken in Switzerland, plus English, because we have some foreign citizens working for Swiss companies that answer those questionnaires. Now, those questionnaires have an history, and this is what you see. This is what you see here. We have a date range, and an interesting thing that you can see here, we have an exclusion constraint So we can have questionnaires that are identified by their name and type, but the validity should not overlap. This makes sense because can you imagine a situation? Somebody wants to fill out a form, a questionnaire on our web page, comes over there, makes a login, and the database returns two different questionnaires. That would be quite confusing for our users. As you can see here, an example, we have now two versions of a questionnaire. One was valid until 2015, end of January, and the other one starts exactly the day after, right? So what does it mean they are different? In this case, you can see those three questions over there have become later only one. Now, it is not our job as IT people to discuss why that should be. You have less information at the end. The reason might be that it doesn't make sense anymore. Economy develops. Some sectors disappear, other new appear. So there are always changes. Now the point is that if somebody, a researcher, comes to us and say, okay, give me all the data for that question, because he knows today we have this question, right? If we go back, we must be able to tell him, look, you can have this question, yes, but until that day, we had actually three questions, so you have to tell me how you want it. Or if you want all three of them with different labels in order to be able to compute yourself some kind of value out of them, right? If we didn't have this information, it would be quite difficult for us to inform our researchers what they have to do or which kind of data they have at all, right? Does it make sense? Well, looks so. Now, the next case, we have to survey participants, which is obviously those companies that answer our formula questionnaires. Survey participants, we keep track information from them. Actually, we need information in order to be able to contact them, addresses, mail addresses, names of people, this kind of stuff. And we also need information about how many people work for that company, because all the answers are weighted using that. Actually, you can imagine that a company having answering the same question for 10,000 employees maybe has a bit larger weight than a company having 10 employees. They might be both very good and everything, but from an economic point of view, the one is heavier. And this information, this is an information that we keep track through time, right? And now I want to make a short digression about what I call the difference between auditing data and making a history of data. The next slide has lots of text. I'm going just to skip it because it would be better if you listen instead of reading. So, right? Now, an audit, you make an audit if you want to have the exact information, a lot of information about every change in every moment. So let's say you start seeing some strange behavior in an application, your data is getting strange. So what you want to do is to know exactly who's doing what changes, what time, and which change, right? You're not going to do it all the time. You just do it when you need it. In that case, you must keep all the information that has been, every change that has been done, you must keep it, right? In a history, it's different. In a history, we just need to keep the data that is useful for whatever purpose the data has been gathered. In our case, is to make calculations of indicators. That means if a company, let's say our secretaries make changes in the number of employees of a company because they receive feedback, the day later or 2 days later, they say, oh, well, I made a mistake, go back, change it again. We don't need to keep all these different changes. The only important value that we must keep is the one that was used at the moment that the indicator was calculated, right? So you save lots of space also. And in particular, you're not going to be confused because you know exactly what has been used for which purpose. So that's what I call the difference between audit and history. Now, maybe you have seen earlier or in other PG days other examples of the usage of ranges. Often what is done, you create a history table, which is an exact replica of what you have, including additional fields, like who made the change and when, right? With a validity. Now, as a matter of fact, you don't need to do that. You can do it if you want to have the information about all the fields, but in our case, the only information that we need to keep is really the weight, nothing more. So there is no reason to keep the whole record of this participant. Wouldn't make sense. Lots of information for nothing that maybe has not changed. We're only interested in changes of this specific field, right? So now you can see here an example. Until that date, this company had 5 employees, and then later 9. It has become a bit larger, so it has more weight. It's going to have a bigger impact in the calculation of the indicators. Questions so far? Okay, the next use case comes from the Swiss PostgreSQL users group, and what we do here is something completely different. The technology behind is the same, but what we do here is actually make the display of some information completely dynamically, right? This is the entry page of our users group. You may probably recognize it. This is a MediaWiki software. It's actually a wiki, so everybody that has the privileges can go there, log in, edit directly the text and whatever, right? That's nice and good. Now we have an agenda, right? What you would have done, let's say, before making a dynamic form of it, would be, okay, now we had an event, it passed, okay, let's go there, log in, edit, move it to another place, to the past events. Maybe we have a new event, enter it, you have to format it rightly, all the stuff. That makes the whole management of this information a bit cumbersome, right? What we did instead of that, we created a small application, a small management application, where you can enter an event, right? Now, as you can see here, we have 2 date ranges. One is used to indicate when the event takes place, from which day to which day. If it's the same day, it's just one day. And when it must be published, right? You can imagine the situation of our small group. What we have, we make lots of presentations like this one here, technical information, technical presentations, but maybe being also, at least partly, a social organization, what we do is maybe in the summer make barbecue, this kind of stuff, right? So we can put it in our agenda, but you don't want to keep the information that we had a barbecue in August 2017 for all the time. So you're going to put here, as soon as the event has passed, don't show it anymore, right? Questions about? This is a good example because as you see here, I entered just to make a showcase, a new event, and now this new event appears here in the entry page as next event. It appears here, right? And at the same time, if all events that are passed would appear automatically down here. So we don't need to edit anything in the wiki anymore, at least for what's concerning the agenda. So it makes actually management much easier. Right. Are there any questions? Either is everything terribly confusing or everything clear? Well, okay. Now, if we take a look into the database of this information, as I said before, you have seen it in the interface. You can enter 2 dates, which are going to be exactly the dates that are in here. In this case, publication starts the 3rd of January 2017, and it's going to be shown all the time. In this case here, duration is just 1 day. In the interface, you enter the same date, because it starts and ends at the same date. So it's your responsibility to modify that in order to have this kind of representation. Remember the first part of the speech where I told you how you should keep close to the standard way of representing, because it makes everything much, well, let's say less confusing, right? Now, this is where the whole magic happens. As a matter of fact, this function here, what it does is nothing else than creating a wiki markup, which is going to be put in the page dynamically, right? Okay, you see, I select from events, and I tell, okay, take all those that are open for publications, right? They must be shown somehow. It's not finished yet. Well, it's still active. What I want to get out here is the next event, which is shown in the enter page, right? It's not finished yet, because those finished, of course, we shouldn't show in the enter page, only in the agenda. Then, in order to get just one, the next one, very simple, classic, what we do is order them by duration. Now it becomes quite helpful to have these comparison operators. So it's not just for indexes. And we take just one, right? What comes out of it is this one here, which is a snippet, which is put directly. Each time that you call the page, the enter page, is going to put directly using that query that I've shown you before. And so that's how it all works. Not really a big magic. So this part here is obviously not very much. You could do the same. Let's say if you have any other kind of information system, you would just modify or create your own function that instead of delivering wiki markup, it would deliver, I don't know, whatever, XML or whatever, right? So, any questions so far? Okay. I told you before that we have the KOF, the institute computes indicators. Probably one of the most important is this one here, business cycle indicators. This is supposed to be something that shows how the development of the BIP is going to be in the next 3 to 4 months. And obviously, if nothing changes. I mean, economic indicators have a quality, which is as soon as they're published, lots of companies and even a government are going to do everything possible in order to make it not happen, especially if it goes down. So our forecasts are usually just as good as a warning, right? So now this information is published each month on the web page of the institute. It's public; everybody can look at it, right? And the point is that everybody should see that only the current values and only at a specific moment. Everybody. There should not be any kind of pre-information to anybody. It is actually an obligation, because this information can be or can become a matter of strategy in some companies. Okay, we know that it's going to happen, it's going to do in that direction, so we should react immediately and do that and that and that, whatever. So there is some kind of danger for speculations. Okay, this is exactly what I said right now. Now, we had so far examples of date ranges, right? Now we have a timestamp range using time zone information. Okay, in our really small country, especially compared with Russia, we don't have many time zones. We actually only have one, so it's not really a big issue. And since the comparison, the extraction of information is done on the database, it's going always to be the same time zone. But for a matter of being complete, we prefer to use this kind of data type instead of just a timestamp without time zone. Okay, here again, we have a key, which is how this time series is called. We have the data itself. Okay, now I'm not going to go into the details, but it's an H-store, a key-value pair, right? A collection of key-value pairs. This frequency now is not so important, and the validity, right? What happened before? We have a group which is called corporate communication. They are responsible for giving out this information to the public. So there was one guy. He had the obligation. Okay, look, now at 9 o'clock that day, you should give out information, right? Now, earlier, the information shown on the web page was not dynamic. Now it is dynamic, so it's extracted directly from the database. What was done before, somebody created a graphic, a static graphic, using the information from the database. And then he prepared a mail, and then at some point in time, he would have almost immediately, or right one after the other, put the new graphic on the web page, send the mail to everybody that must be informed, to keep it as close as possible. You can imagine this is not really the most efficient way to do things. What we do now is different. What we do now, we have this validity, which indicates which information must be given. There is always only one time series with this key, which is valid at a specific point in time, right? Okay, now instead of sitting over there 9 o'clock in the morning, waiting with a clock, we are Swiss. We really like being exact in time. So what we do now, you can compute this information every time. Usually it's about around the 26th or 7th of the month. It's published the first day of the next month, usually. So, well, what you can do now, we have a current value, which we update, and we set now the end of this of the display of this information to a specific date. Now I put now here just as an example, but you would have here, let's say, 1st of January 2017, 0900, right? With a time zone, of course. You do that in a transaction because as soon as you have changed this information is not going to be, possibly not going to be displayed anymore, depending on what you put in there. As the next point, you put the new information, which is exactly the same as before, with an additional value. And you put the starting date, time, at the same date time that you put the other one. They don't overlap, because this one here is excluding, and this one here is including, right? Commit, and all the magic is done. Now we have 2 entries in the database, but only one of them is valid, right? And now that when somebody goes onto the web page and retrieves this information, that graphic, that time series, is going to get only the one that is currently valid at a specific point in time. So I can do it anytime. All the information has been computed, I put it in the database, and I can go for a coffee, because everything is going to happen by itself, completely automatically. Now, as you see, in order to be able to extract information that is current and not all of them, we need a filter, some kind of filter. What used to be done is using a view. You could create a view, put specific privileges on that, so that the web page would call this view instead of selecting directly from the whole table, right? This is good and nice. It's one possible way of doing it. But there is a better way. How many of you already heard of RLS, row-level security? A few, right? This is quite a nice feature that was introduced in PostgreSQL 9.5. And basically, row-level security is a way of filtering rows based on some specific criteria, right? The nice thing of it is that you can be very specific to which users or group you are giving which privileges for which operations, right? It can be very, very, very detailed. Here is an example. We have a user or a group, public access, that is used by the application that displays the information in the web page, right? And for select, we tell them, when you make a select, when this user makes a select on the table, only select those that fulfill this criterion here. As you can see, at the end, this happens to be exactly the same as here, right? Why is it better? Because first of all, you don't have to create a view. You manage your privileges and your access to the table horizontally in the table itself using the policy. So, and it's much actually more efficient at the end, right? So, by the way, just as an information for those of you that don't know about row-level security, if you are going to use it, read the documentation. It's very interesting, very good, very well done. And what happens usually or often, if you start using it for the first times, is that you forget to enable the table to use row-level security. It's not automatic. You have to do it explicitly, right? Right. Now, the owner of the table is not has no restrictions, so actually he can see everything. That would be kind of an administrator of this information. He can look at all entries in the database without having any filtering. The web application is going to be in public access, and it's going to see only the value that is currently valid, right? This is exactly the idea behind it. You publish once, and then you forget about it. Everything should go by itself, and actually it does. Very stable, very good, and clean. So, any questions so far? Then I will come to some conclusions. We have seen some possible use cases for ranges that have to do with time and dates, right? You can make histories of your data. Sometimes it's necessary, sometimes not. You can even make auditing using the same technology. You can create time-responsive entries, so you decouple database information from your processes, right? Or you, better said, you integrate them in a different way. We have seen how this way of solving problems can be integrated quite well with other existing features of PostgreSQL. In our case, that was row-level security. And yes, they can be indexed, which is also make any search much quicker. This is quite normal, quite typical. So, well, questions?
So we have some time. Do you have any questions? Okay.
Can you please open the slide number 27? Thanks. There's a second condition with upper duration. There's one problem. We can be sure if that upper bound is included or not. So if I don't know actual data, I can't just use these operators. I used to write some long case statement with check for including upper bound. So maybe you know some more simple way to do that.
Well, yes and no. It's a matter of creating conventions. What we did is my recommendation was to use always the default way of storing range informations. And if you do that, you know that. I mean, we are the same. The person who creates the database and the deselect statements is the same person. So actually, at the end, we know that it's always going to be so that the lower bound is included and the upper bound is excluded. So we do it through convention. But as a matter of fact, yes, if you don't know, if you must make a sim query using any kind of data that you don't have exactly an idea about, then you have to check also if the bounds is included or not.
Okay.
So anyone else?
And what can you tell about the performance? For example, comparing to storing 2 dates, separate columns with 2 dates, and this type.
I don't have a really a benchmark about it, but SQL comparisons. You would have 2 columns, and you would have some kind of between that and that. And it's known not to be the most efficient way in selecting rows. Since it's implemented in the, it's built in using ranges. It's built in the application. It's coded in C. It's much more efficient. Yes, but that's not the only good reason in order to use ranges. Well, if you don't need ranges, don't use them. But if you are going to use ranges, it's much easier to manage the information. I mean, if you have 2 columns, you must have trigger functions that take care of updating and changing the information as you need it. With ranges, you have it more or less for free.
Anyone else? So thank you, Charles. Now we have lunch for blue tickets.